Dear students, myself Sanjeev Goyal. I am working as senior lecturer at Government Polytechnic College Bathinda. Today our topic of discussion is transducers that are variable, resistive, capacitive and inductive transducers. First of all, there is a law of conservation of energy, that is energy can neither be created nor be destroyed. It can only be transferred from one state to another state. According to this, transducer is a device, usually electrical, electronic or electromechanical, that converts one type of energy to another for various purposes including measurement or information transfer. It must produce the output which depends on the some way on the input quantity. That means transducer is a device which is used to convert one physical quantity into another physical quantity, and that output depends upon the input. Its output will depends on its input if it processes upon the actual input. So transducer extracts some energy from the measurand medium. Some energy is also required to convert the input to output. This energy can be supplied from outside or by the measurand only. According to that, transducers are divided into two categories: active transducer and passive transducer. Active transducers are those transducers which does not require an external power supply to convert input into output signal. These transducers usually rely upon magnetic inductance or piezoelectric property to produce their output signal. That means the transducers which does not require any external power supply are known as active transducers. For example, piezoelectric crystal used for acceleration measurement. To measure the acceleration, piezoelectric crystals are used, which is a category of a active transducer. In active transducers, measurand is converted into output without any other form of energy requirement. Without any external energy, measurand is converted into output. These type of transducers are also known as self-generating type of transducers, because they are the power supply is given internally without any external source. Second category is passive transducers. Passive transducers need an external power supply in order to amplify the input and generate an output signal. All passive transducers change one of or a combination of, either it changes one parameter or combination of these three circuit parameters. These are resistance, inductance or capacitance. So all passive transducers works on the principle of changing either one parameter or combination of these three parameters. These parameters are resistance, capacitance or inductance. For example, potentiometer is used for measurement of pressure, displacement and position. It is an example of passive transducer. For any type of transducer, there are some basic requirements. First is linearity. Linearity of any transducer is the prime requirement. A transductor having linear input output characteristic is a big plus. So a transducer must have linear relation between input and output. Second requirement is repeatability. A transducer having this quality produces the same result again and again when the same input signal is applied under the same conditions, that is temperature, pressure and humidity, etc. That means there is no variation in the output of a transducer if same input is applied in the same environment, same conditions. Third requirement is ruggedness. A transducer should be robust in construction. It should be mechanical rigid so that it is capable to withstanding overload. Fourth one is the high signal to noise ratio. The quality of output signal of transducer should be good. It should be free from any type of internal and external noise, so that there must be high signal to noise ratio. High reliable. Output of the transducer should be highly reliable and stable. It should be precise. Precise means it is up to mark. It should give minimum error. in measurement for temperature variations, humidity variations, etc. So, the output of the transistor should be highly reliable. Good dynamic response. A transistor may be called upon to respond to either slowly varying or dynamic signals. Its output should be faithful to input when taken as a function of time. So, either input varying slowly or varying very fastly, there must be a good dynamic response. There is the output should be always faithful to its input with respect to time. No hysteresis. A good transistor is free from hysteresis. It should not introduce any type of hysteresis during measurement while input is varying from its lowest value to its highest value and vice versa. Next requirement is residual deformation. There should be no deformation of testing material after the removal of any pressure after long period of application. In no case there should be any deformation of the material after the removal of the pressure for the measurement application. There are basically three categories of transducers, working principles of transistors, that is variable resistance, variable capacitance and variable inductance. So, first of all is variable resistance type transistor. The variable resistance transistors are one of the most commonly used type of transistors. The variable resistance transistors are also called as resistive transistors or resistive sensors. They can be used for measuring various physical quantities like temperature, pressure, displacement, force, vibrations, etc. These transistors are usually used as the secondary transistors. This is a very important point. These variable resistance type transistors are generally used as a secondary transistors where the output from the primary mechanical transistor act as the input for these variable resistance transistors. So, these variable resistance type of transistors taken their input from primary transistors and they act as secondary transistors. The output obtained from it is calibrated against the input quantity and it directly gives the value of input. So, these type of transistors give directly the value of input quantity. The basic principle of working of variable resistance type of transistor is that the variable resistance transistor element works on the principle that the resistance of the conductor is directly proportional to the length L of the conductor and inversely proportional to the area A of the conductor. Therefore, for example, if L is the length of the conductor in meters, A is the area of conductor in meters square, its resistance R is given as a rho into L upon A, where L is the length, A is the cross sectional area in meter square and rho is resistivity of the resistance material which depends upon the particular material. So, the resistance can be changed if any one of these values, either rho, either L length or A is changed. Measurand, the quantity to be measured, is connected to the resistance in such a way that it varies any one of its parameters. Any one means rho, L or A. A change in the value of R is proportional to the measurand. Thus, the measurand can be measured by measuring the change in resistance. So, change in the resistance actually indicates the value of measurand and the value can be changed either by changing the length of the conductor, A area of the conductor or rho that is the resistivity of the conductor. Rho is called as the resistivity of the conductor material. It is constant for the material and measured in ohm meter. For a particular material, this value is always constant. The resistance of some materials also changes with the change in their temperature. Apart from these three values, rho, L or A, there is another parameter upon which the value of resistance depends, that is the temperature. This principle, that is change of resistance with temperature, is primarily used for the measurement of temperature. So, apart from these another three parameters, there is another parameter temperature, due to which there is the change in value of resistance. So, this property can be used to measure the temperature. Some of the variable resistance type of transistors are, first one is the sliding wire, also known as potentiometer, strain gauge, load cell, RTD, thermistor, hot wire anemometer, carbon microphone, humidity sensor, etc. The example is potentiometer. Potentiometer, also known as POT, POT, is a 3-terminal resistor with a sliding contact that forms an adjustable voltage divider. So, it is a 3-terminal device, 3-terminal resistor with one terminal is sliding, one terminal is movable. If only 2 terminals are used, one is fixed, one is wiper, that is movable, it acts as a variable resistor or rheostat. So, potentiometer acts as a rheostat or variable resistor in case only 2 terminals are used, that is one is fixed one and other one is a variable, that is known as a wiper. If there are 3 terminals, 2 are fixed, third one is the variable movable, then it is known as a potentiometer. Potentiometers are commonly used to control electrical devices such as volume control on audio equipment. When we are controlling the volume of an audio equipment by moving that knob, actually we are changing the resistance of the potentiometer. The potentiometer is a displacement transducer. This is a passive transducer. Passive means it needs an external supply to change input into output. It consists of a resistive material whose length is proportional to its length, whose resistance is proportional to its length. So, by varying the length we can vary the resistance. Slider displacement is proportional to output voltage. So, when we move the sliding terminal, we get variable output voltage depending upon the input. The most common problem in these type of transistors is dirt, the dust which comes under the slider. In potentiometers, one end of the conductor is always fixed. The position of the other end is decided by the slider or wiper with a movable contact. This contact can move along the whole length of the conductor. So, by moving the slider, actually we change the length. So, when the body moves, the slider also moves along the conductor. So, its effective length changes, due to which its resistance also changes. The effective resistance value is measured between the fixed position of the conductor and the position of the slider movable contact. This change in resistance is calibrated against the input quantity, whose value can be measured directly. So, the value of the input quantity can be measured by the value of the resistance. This is a diagram of a potentiometer. In this case, this is a movable contact which is having this is known as a wiper. This is fixed contact. By moving this wiper along the length of the conductor, we vary the resistance, and this variable resistance, the value of this resistance is calibrated against the input quantity directly. This is again potentiometer. This is a model of the potentiometer we actually used. In these there are 3 terminals, 2 are fixed and third one is the movable. These are the another diagrams of potentiometer, 2 types of potentiometer. In this there is a movable contact. This is a resistive material on which this contact moves, and as the contact moves, the length of the material changes. Again, this is a circular type of potentiometer in which this is a shaft with which we move the wiper, and by moving the wiper we can change the resistance. Thermistors, the next category of variable resistor type of transducers are thermistors. Thermistors are thermally sensitive resistors. That means these generally made up of semiconductor materials. That means these are the resistors which vary with the temperature. So all resistors vary with the temperature, but thermistors are constructed of semiconductor material with the resistivity that is specially sensitive to temperature. That means whose resistivity depends upon temperature. This change in resistance predictably with temperature. The resistance change with the temperature. There are two types of thermistors used. One is the two types of basic models are used. One is the positive temperature coefficient units PTC, and other one are the most thermistors have a negative temperature coefficient NTC. PTC means their resistance increase with the increasing temperature. NTC, negative temperature coefficient, means their resistance decreases with increasing temperature. So there is a inverse relation between resistance and temperature in case of NTC, and direct relation between resistance and temperature in case of PTC, positive temperature coefficients. The thermistor is an extremely non-linear device. The price we pay for this increased sensitivity is loss of linearity. To get high sensitivity, sensitivity means output changes with the input. If there is a small change in input, then small change in output. If there is a large change in input, again there is a large change in output. That means output also always follows the input. This is known as sensitivity. But to get this high sensitivity, we lose linearity in this case. These types of transistors are usually connected to an electronic circuit that reads out the temperature digitally. So these thermistors are generally used to read out the temperature digitally. In thermistor, there is a expression used, R is equal to Rho exponential beta into 1 upon T minus 1 upon To, where R, capital R, is the resistance at temperature T in ohms. Rho is the resistance at temperature To also in ohms. Beta is constant, that is characteristics of material, and T and T0 are absolute temperature, two types of temperatures. NTC, negative temperature coefficient thermistors, operates over a range of minus 200 degree centigrade to plus 1000 degree centigrade. NTCs should be chosen when a continuous change of resistance is required over a wide temperature range. So when there is a continuous change of resistance is required, we use NTC type of thermistors. These type of thermistors offer mechanical, thermal and electrical stability together with a high degree of sensitivity. The major advantage of these types of transistors are their high degree of sensitivity, whereas PTC, positive temperature coefficient thermistors, are temperature dependent resistors manufactured from barium titanate and should be chosen when there is a drastic change in resistance is required. Whereas in case of NTC we use word continuous change. In this case, PTC case, we use word drastic change in resistance is required at a specific temperature or current level. So therefore, NTC thermistors are widely used as compared to PTC thermistors. This is a diagram of thermistor. Advantages of thermistor: inexpensive, they are having very less cost, rigid, rough and tough, reliable, their results are up to mark, respond quickly, highly sensitive, they are manufactured in a wide range of shapes, sizes and values. Third type of variable resistance type of transducer is used for humidity measurement. Humidity is the amount of water vapor in the air and humidity measurement is the measurement of this relative amount of water vapors present in the air. The humidity can be expressed in different ways, that is absolute humidity, relative humidity, and dew point. Devices that indirectly measure humidity by sensing changes in physical or electrical properties in materials due to their moisture content. Moisture means water contents, are called as a hygrometer. The three major instruments used for measuring humidity in industry are electrical hygrometer, psychrometer, and the dew point meter. These are the three types of meters devices. They are used for the humidity measurement. Humidity is the water contents in the air or in any type of other gas, etc. In this we change there is any change in the electrical or physical property of the material due to the moisture contents can be measured, and these materials are the electrical hygrometer, psychrometer, and the dew point meter. This is a digital model of humidity measurement. 29.9 degree centigrade shows the temperature, whereas this 59% shows the relative humidity at that particular time. A resistance hygrometer, it is an electrical hygrometer. It is an active transducer, so it does not need any external supply. These instruments are suitable for measuring moisture levels between 15 degree and 95 degree. So they can get minimum value 15 degree and maximum value is 95 degree moisture level. It has typical measurement uncertainty of 3%. Atmospheric containments and operation in saturation conditions both cause characteristics drift. There may be drift in the characteristics of these type of hygrometers due to the atmospheric containments and operation in the situation where condition depends. The basic principle of these resistance hygrometer is that some hygroscopic salts exhibit a change in resistivity with humidity. A resistive hygrometer humidity sensors use the change in resistance of a hygroscopic material. So hygroscopic material is that in which there is a change in resistance due to the humidity. So in these type of hygrometers, there is change in the resistance of hygroscopic material between two electrodes on an insulating substrate. There are two electrodes pasted on an insulating substrate, and due to this there is change in the due to the humidity level, there is a change in the resistance of this hygroscopic material. The hygroscopic material salt is deposited between these two electrodes. The resistance of the element changes when it is exposed to variations in humidity. When there is change, then when the humidity changes, the resistance of element changes. The resistance hygrometer should not be exposed to condition of 100% humidity, as the resulting condensation may damage the device. So we already say that they can get maximum humidity up to 95%. These are accurate to within plus minus 2.5% to plus minus 2.5% or otherwise plus minus 1.5% in some cases. Their response times are typically of the order of a few seconds. They are somewhat slow devices. Applications: humidity sensors can be used not only to measure the humidity in an atmosphere, but also to automatically control humidifiers, dehumidifiers, humidifier where we wants humidity, dehumidifier wants less humidity, air conditioners for the adjustment. Then strain gauge pressure transducer. When the tension is applied to electrical conductor, its length increases whereas its cross sectional area decreases. With the change of length and cross sectional area, its resistance changes. This change can be measured and it can be used for the measurement of force, stress and strain. A strain gauge is a passive type resistance pressure transducer whose electrical resistance changes when it is stretched or compressed. So, it is a passive type of transducer. So, it needs an external supply for its working, and in which resistance changes. So, it is a variable resistance transducer in which the resistance changes due to whether it is stretched or compressed. A pressure transducer contains a diaphragm which is deformed by the pressure. The shape of diaphragm is deformed by the pressure, which can cause a strain gauge which is connected to diaphragm to stretch or compress. This deformation of the strain gauge causes the variation in length and cross sectional area, due to which its resistance changes. The wire filament is attached to a structure under strain. So, the structure that is to the gauge, there is a wire filament is attached, and the resistance of that strained wire whose length or area change is measured. This is a diagram of a strain gauge. Here is a diaphragm. To the diaphragm there is connected a wire, strained wire is connected, and with the change in the deformation of the shape of diaphragm, there is change in the length and area of the wire filament. Strain gauge pressure type transducers, construction and working. These are the other two types of strain gauges. First is the wire resistance strain gauge. Second is the double bonded strain gauge. In these both types of strain gauge, there is a diaphragm. This is a diaphragm, and with the pressure, there is a change in the length and the area of this wire, and with this change, we get the change in resistance. This is again this diagram. These are the lead wires, force applied. So, this is the flexible backing. This backing is movable. So, when we applied a force, there is a change in length and area of the wire. Strain gauge pressure transducers are used for narrow pressure span and for differential pressure measurements. These are available for pressure ranges as low as 3 inches of water to as high as 2 lakh size. Inaccuracy ranges from 0.1% of span to 0.25% of full scale. Then next is a resistance temperature detector, RTD. RTD are the resistance temperature detector devices, are conductors used for temperature sensing. They can be used in bridge method as well as ohm meter method to take the output. The change in resistance of material per unit change in the temperature should be as large as possible. The material should have high value of resistivity to get required value in less space. Resistance and temperature relation should be continuous and stable. Platinum, nickel and copper are the most commonly used. Tungsten and nickel alloy are also used. Application of RTD, they can be used in average and differential temperature measurement. Differential temperature sensing to an accuracy of 0.05 degrees centigrade have been accomplished in a nuclear reactor coolant heat rise application. So, they are used in nuclear reactors having accuracy of 0.05 degree centigrade. Then second type of category is variable capacitance type of transducer. A capacitance is a pair of parallel plates with some insulating dielectric material between them, which can be used to store an electrostatic charge. So, in capacitor there are two plates, parallel plates having some insulating dielectric material between them, and it is used to store the electrostatic charge.